Awesome. So yeah, I'm here to talk about challenges of big infrastructure monitoring. So a little bit about myself. My name's Sean Porter. Lovely intro, by the way. I'm the creator of Sensu, the open source monitoring project. I'm an operator at heart with over a decade of experience automating and monitoring large infrastructure. And I go by Porter Tech on social media and a lot of normal communication mediums like IRC, live on IRC. So first I want to take a few moments just to talk about our shared reality as operators and developers, where we kind of live on a daily basis. I mean, software is incredibly complex. I don't think we disagree on that fact. And the infrastructure that it runs on, that is driven by, is at least as complex as the software, but generally I see it's more complex. And as time progresses, that complexity just keeps on climbing. And there's really no stop there. I mean, it's not, exponential growth. It's fairly linear, but the outlook does not look good. It's fine. I think we're all comfortable with this reality. I don't think we disagree with it. And to go along with this rising complexity, as the unit of things that we manage decreases, becomes smaller, there are more of them. As new technologies come, they kind of layer upon each other. We went from bare metal hosts, servers, to VMs, to containers, and now functions with function-based computing. And to top that all off, it's becoming ephemeral, right? Things are around for a very short period of time. That's the new normal. I think we're kind of used to that short-term life cycle, even in larger infrastructures. It's fine. Multi-generational infrastructure is a thing. As complexity is increasing and technologies are changing even faster, more rapidly, we can start to work on a project, and then a year or two later, we're moved on to new technologies, but those old technologies are still incorporated into our overall infrastructure. I mean, old is forever, new is exciting and fleeting, and it becomes old real quick. And really, you end up with this full spectrum of technologies. You've got some stuff on bare metal, some on VMs, some on containers, some on functions, different APIs. You got SOAP, you got REST, a whole hodgepodge of technologies with the overall objective of running a business. This is a terrifying statistic. From 2017, in Q4, IBM's mainframe business grew by 32%. Terrifying. Jobs are still run on mainframes. So what you end up getting, whether you're a small startup that you've been around for a year or two, or a large organization, you end up with a potpourri or a trail mix of technologies, right? A nice smattering, and overall it's okay, and we have a decent feeling about it. So this is our shared reality, and if you don't think you fall into this category, this bucket, come find me afterwards. I want to see if you're just delusional, or you have some insights that I lack. So big infra is what I'm here to talk about, and I put quotes around it. It's definitely something that we romanticize. We're like, ooh, big infra. I always want to work on infrastructure that large or at that scale. But really, it just amplifies all these problems in this reality that we all live in. I think for most large infrastructures, they fall into organizations that are at least 10 years old, just because that's the amount of time it took them to accumulate the wealth, the people, and the technologies. So these companies also have organizational problems or siloing or different business units, and they all have to interact with one another. There's also politics, and that just further amplifies these problems. Over time, they all individually gather their own tools and preferences and practices, and then naturally, you just throw a few more on top, and it's okay. This being containers and burn it to the ground and a chainsaw. You can align it. Netflix is actually a really interesting example. I think we all kind of put them up on this pedestal as a technology platform. I mean, they have dedicated, I think in 2019 they said they're going to spend $1.3 billion on technology for their product. Who knows how much of that's going to Amazon. But what they've said previously, and they keep reiterating, is monitoring for them is a 2-digit % of their infrastructure cost. So I imagine that number is really big, but I don't have that number. So all these organizations, they do what they create, or what called data lakes, or this idea of getting all their and funneling all their data into one place so that they can query it and do interesting things with it and have that holistic view. In reality, with big infrastructure, you end up with multiple data lakes, and they end up being siloed on themselves. So this presents an interesting problem. You also have the square peg round hole situation. This is a screenshot from a fantastic movie, Apollo 13. You should all watch it again. But the idea is that they have it in this one. They have this problem on the spacecraft, and they need to get the scrubber into this other size, and they've only got these materials to work with. But what we end up with is we have data in one format. We need to transform it, get it to another one, so it can get into one of these data lakes. A good example of this that falls into these organizations that are 10 years or older is the service check, the venerable service check. And what I like about service checks is it's a fantastic way of codifying symptoms of a problem, right? And we can share these codified symptom detectors, whether they got the shivers, they're got an upset stomach, or they're farting. A service check is just a script that outputs some information to standard out, use an exit status to indicate whether it passed or failed. If it fails, it's usually like it's down. Exit to critical. It can also bring along all this information and context and telemetry data, which usually just gets thrown out. But if we have a system that can process it and do interesting things with it, we can use this, what can perceivably be seen as a legacy technology, in new and exciting ways. So really, tools like Sensu or ElkStack or anything else that is built around this idea of pipelines can really fix that round peg square hole problem for you, as well as allow you to write to your multiple data lakes. But it still doesn't solve the last piece. But really, it's all about composability, about creating the overall solution, the flexibility for these large infrastructures. Grafana is a fantastic tool because it's the final layer, right? It's able to pull from these multiple data lakes and visualize all that data and give you that holistic view of your overall system, your multi-generational, siloed, multi-data lake, 2,000 different format infrastructure. So really, this was just a quick talk about my experiences and what I've seen with big infrastructure. I would love to talk about it more in depth. However, I do not have the time. Really, I wanted to set up the stage for the next speaker, Nikki. She's an engineer at Sensu Inc. And she's going to demonstrate how Sensu can extract telemetry information and kind of solve some of these problems that I've laid out here for you. So thank you all very much.